mark you as not. They mark you as absent.
Really?
Yeah. Even if you put your name in the chat.
All right. Let me get a link to this playlist.
Oh. Oh. You'd probably talk to him about it, and he'd be like, "Get one," and then he'll mark you absent, and then you
Then just mark you absent for in perpetuity.
He would probably advise you to drop the class.
I feel like that would not.
Or
what if you don't have a good enough PC that
All right, I'm pretty sure. Okay, so before you put out this thing where it's like required like computers for custodian now, you have to have. You can't have. You're not supposed to have Chromebooks anymore because you can't download responses.
You can't download responses.
Thank you for banning Chromebooks.
Hey, why don't do respondents have a Linux?
All right. Shut up. Everybody shut up.
All right, sorry.
Okay.
Feels like I haven't done that in a while.
I know, I'm about to say.
It felt good. All right. So I just put a link up on Blackboard. I'll do it for the other classes as well. And do I already have the CUW Wi-Fi info? I don't. I'll put it up here today. I actually have it here, but if I put that document on the video, it'll show you a zillion passwords for a whole bunch of different stuff. But anyways, I'll just give you the highlight reel real quick. Let's see. Is it this one? This one? Yep. So I have a whole bunch of videos up there now for, we have our virtual machine thing set up. So I have one video, and each one's kind of like a short little thing just specifically for that skill you need to do, rather than, an hour-long video with everything in it. So if you don't know how to join the CUW CS Wi-Fi network, this will teach you how to do it. I will put up the username and password on our Blackboard, because you will need that password. That's not something you should hand out to other students. That's something that is accessible within the CS department, also by the makerspace in the Plaster building. Technically, it's currently available throughout campus, but Mark Newhouse, I think, doesn't want that to remain that way, so it's possible he might turn that off. But FYI, I talk about a lot of those things in the video, but this 2-minute video teaches you how to connect to the hidden computer science Wi-Fi. Then I have another one that shows you how to reach the virtual machine server here in the department. Then I have another one that if you want to install Ubuntu Linux yourself, fresh install on our virtual machine server, you can. I'll put another one up that has you install Windows, but it's following the same thing. Then we have one that after you've installed Ubuntu, what stuff you might want to install on there. We put Visual Studio Code on there. I put VNC, actually, I don't put that on that one. So I put Visual Studio Code in there, and I put the Open VNC or Open VM tools package. So I show you how to install software on Linux a couple different ways in that one, and also get the operating system patched. This video is installing Real VNC server on your virtual machine, which then would allow you to, if you live off campus or something like that, you would just need to be here one time to get your machine set up. Then from off campus, you'd still be able to reach your virtual machine using VNC Viewer. So that video talks about all of that. And then this last one, which is just finished uploading, so now you know I'm not lying. I was in my office doing that. This is how to clone a virtual machine from a template. All right. Now, that's going to be your homework for Thursday. That's at least going to be your homework for Thursday. So follow these various videos to, if you're interested. You will need to do the CUW CS Wi-Fi video first. That's going to be your required first video. So it'll be 2 minutes out of your life. And then the last one will be to clone a VM from a template, where I take you through cloning Ubuntu Linux into our virtual machine. Even if you already have your own Linux install on your computer, that's okay. You can use that for your homework assignments and stuff, but still go through this process of establishing a virtual machine that has your name on it, changing the password, stuff like that. It'll be a good exercise, and you might find other uses for that in the program. Go ahead.
In order to clone the virtual machine, do we have to be connected to CWCS Wi-Fi and do that here, or can we do that from home?
No, you'd have to do that from here. Yeah, and it takes between this video and this video. So this is what these are 10 minutes long total. The cloning process takes 5 minutes. So I'm asking you to dedicate 15 minutes on campus, and you could do it immediately following class if you if you'd like. So let's actually go ahead and these other videos are interesting in terms of accessing that. You'll actually need to do this video, then this video, then this video. 3.
That's too much time.
So it's now we're at 17 minutes. All right. So let me go ahead and let's put that up as I am sharing the screen here, aren't I? I am? Okay. So we'll do homework number 3, VM setup. So watch the videos for connecting to CUWCS Wi-Fi, connecting to vSphere, and finally cloning a VM, cloning a VM from a template using the CUWCS tutorials link on the left side of Blackboard. And you should have your own Ubuntu Linux virtual machine. On campus. Submit a screenshot of your running VM. I guess I'll just verbally say, if you are somebody who is remoting in from off campus and you are have the documentation that says you are allowed to be completely remote and you are not able to come to campus, just send me a message, or when you submit the homework, just put that information in there. And then, obviously I'll give you credit, or we'll find an alternative for you doing this. In that case, you are probably going to be installing Linux on your own, or you're going to need a helper. So if you do know somebody else from class, maybe they'd be willing to sit down, and while they're doing it, you can be on Zoom with them and they can do it for you as well and set up the VNC server. Doesn't take that long. With your account information, so you'd be able to access it from off campus if that is your desired way to work on your homework instead of having your own local Linux install. Okay, so there's a way around it, but if you don't have physical access to campus for legitimate reasons, then get on Slack and see if you can find a friend who will help you walk through it. Okay. So I'm going to assume you have this done before class starts on Thursday. Okay. And when all is said and done, you should have Linux effectively running inside of a web browser, or there's other ways of launching it, but this is using our virtual machine here on campus to run this. you know, it's not the fastest way of doing it. I would say the preferred way would still be running your own copy of Linux. It'll be peppier and stuff like that. But if you have a laptop that doesn't have the most system resources, and you, so if you wanted to run your own virtual machine, like with VirtualBox or something, if it slows your machine way down, you might decide, oh, I'd rather do this and not use my own system resources. I'll use the virtual server's machine resources to do it. But I would still say, in the examples, when I do it in classes, I'll run my local copy of Ubuntu in here, which is the same version that's in the virtual machine. But that's the scoop. Go ahead.
You said you're gonna show the password for the Wi-Fi, right?
Yeah, I'll put the password up. I'll put it up. Well, that's not the password for the Wi-Fi. It's pretty much my sample password for everything else as you go through the tutorials. But I do have you change your password to whatever you want in the last tutorial. Yeah.
Just to make sure I'm hearing this correctly, so even though we never, like, I have my own.
Yeah.
copy of Ubuntu, should I still go through the-
Yeah, I still want you to go through this because it is a beneficial skill. Let's say that you are in a security class with Dr. Wall, and he's going to have you install Kali Linux or something like that. Or you want to experiment with another operating system. You want to put Windows Server on or something like that. You can go in and use our virtual machine server to do that kind of stuff on your own and experiment with a computer or something like that. That's what it's there for. We wanted people to utilize it. So this will give you your crash course on using that thing, even if you end up not using it for this particular class for doing your homework. Go ahead.
If you got like a virtual machine of Windows, would you have to pay for Windows? Or is there a way to get it?
Running on our virtual machine here, no, because you'd use the education version, which is free to use for education purposes. Yep. But keep in mind, it lives here on our hardware. You're just viewing it through a window. And when I do the tutorial, I'll make sure I select the education version because from a licensing perspective, I mean, if you have a Windows Professional key, you probably could put it in there at work. The enterprise version, I don't think would actually work. On campus, you can run the enterprise version, but you have to be connected to the faculty network in order to have it authenticate with our authentication server. And this is a segregated a network that they have us on. So I don't think we would have access to it. So I mean, education version is the same thing. So you install it as long as you're using it for education purposes. I think that's a legit use of the license. You know, if you're not using it for that, I don't want to know about it. And you're the one that's in breach of the licensing stuff, I guess. All right. So in any case, that's the, so go through those videos and make sure you understand our setup. You know, so basically at the end of the day, what you're going to end up doing is coming in here, right clicking on this and saying new VM from this template, and then waiting 5 minutes and you have a virtual machine. Change your password, you're good to go. Okay, so not a major ordeal to set up. Okay, so for today, you were looking at the differences between C, C++, and Java and C# from the perspective of structs and pointers. We kind of gave a high-level overview of this last class. Anybody find anything of interest? We'll chat about it for just a couple minutes, then we'll jump in and start writing some C++ stuff. So anything of interest that you found in looking at this? Go ahead.
I forget, I think it's C++. It was saying that structs, they're like fields or instances are like methods, not methods, but the fields are actually by default public and classes are by default private. So like I guess structs are less secure than classes. Would that be valid to say?
That's probably a fair, but by default.
Yeah.
Yeah, that they would be less secure because of the way you're using them. I mean, typically a struct is used for passing around just a collection of name value pairs where presumably You want everything to be public, right? Because you're probably just going to say, I want this struct's first name, I want this struct's last name, I want this struct's age. You want to have direct access to it, where when we've looked at creating objects before in like, for instance, Java, we typically lock everything down, make it private, and then loosen the reins a little bit as we need to. And we give access to things through like getters and setter methods and things like that. So kind of, it makes sense for the default to be private there. Because you almost think about it as the correct use case. If you're just creating a scenario where you want to have stored name value pairs, the equivalent of like a Python dictionary, you'd rather it just be public by default. If you need if you need more control over it than that, that's when you might start considering going to a class type situation. All right, what else? We see anything else? Go ahead.
I was just wondering, like, why did C# add struct? Because like structs and classes are different, but I feel like I found that I thought classes were just kind of struct, but like,
well, right, but didn't we mention at last class that by default structs are passed by value, where classes are passed by address?
I just don't really know when, like, in a situation when that would be like very helpful. Because if a struct is like really big, then wouldn't it be passed by value be kind of like slower?
But as the programmer, you get to choose. So in C++, we can say, I want to pass this struct by address because it's too big. I can choose to do that in a language like C and C++. In a language, so the idea is that we have a dictionary type data type, collection of name value pairs that passes kind of like as an int by default. And like you said, if the struct isn't gigantic, maybe that makes some sense. But if the struct is gigantic, the programmer is then empowered to say, look, I'm going to pass this by address because it makes more sense to do that in this case. So you have the flexibility as a programmer to make those decisions, where that was taken away from you entirely in Java.
So
Go ahead.
in that case, where like the programmer like decides which one to use, if you decided to pass a struct by address in C#, would it just be better to make a class for it, or would it be better to pass a struct by address?
I would say it would still make sense to make a struct for it, because unless you needed some of the additional abilities of a class. I mean, I think a class would be heavier weight. You know, there's more management stuff that goes into a class doing all of its extra stuff, that if you're not going to use its methods and constructors and that kind of stuff, you know. But to your point, you could, right? You could just do everything in a class and say, hey, I know how this is being passed by default, and I'll be careful. And you could probably pull off everything you wanted to pull off. And every now and then when you needed to do something specific and the default behavior wasn't what you needed, you just create the hack that time. But they give you both, that way the programmer to decide what they want to do. You have a question?
Oh, no, never mind. I had one, but I don't have one anymore.
Okay. All right. Anything else we found? So end of the day, probably use the right tool for the job. But more importantly with structs, and we're going to see this when you take the 450 class, as a computer scientist, we need to make sure we understand structs, because we're going to see a lot of older code that's written in terms of structs. And even modern day systems programming, if we're writing software to talk to the Linux operating system, for example, you're going to have structs all over the place. It's a data type that we need to be aware of, and it's something that came from C, was still there in C++. Java took away from us, C# brought back. Having said that, and to your point, if you're a C# developer, you're probably, and that's your whole world is C# development, you quite possibly may not use structs very often or ever, right? And maybe that has to do with, it's probably not that common that we would create a object that didn't have some functionality to it, a constructor or some methods or something like that, even if we really we're primarily using it for storing name value pairs. All right, so let's go and start writing some stuff. Now we've already written hello world in C and C++, right? We've looked at the format or the syntax for the star this and the ampersand this and that stuff. So now we want to start looking at creating some classes using our using C++. Okay, so I'm going to just remind myself where we are in here. I'm not sure why I put that inside this folder, but that's okay. All right, so I'm going to go ahead and I'm going to create a make directory. We're actually going to do this because we're going to ultimately put it up on GitHub, right? So we're going to kind of go through a little bit of a GitHub tutorial here. Now you can get, pun intended, I think you can get Git desktop. For Linux. I'm not going to use it anyways. I'm just was interested if they did have it.
I don't think they do.
Okay, well, good. But we're not going to use it. We're going to use the command line version of it because, again, getting some command line ability in here is going to be a good thing. So, yep, but you're going to learn how to use it from the command line now. So we're going to go ahead to GitHub. And I'll go ahead and sign in. All right, and I'm gonna, so once you're in here, I wanna go ahead and create a new repository on GitHub. And this is probably the way you always wanna start because it gives you a cheat sheet for the commands. All right, so we're gonna create a new repository and I'm gonna call this guy CSC300 Spring 2021. We'll call this guy GitHub tutorial. Pretty long-winded thing, but I'm creating that. I'm going to make it a public repository. That was the default here. I'm not going to add any README or git ignore or anything like that. So I'm just going to go ahead and click create repository. Okay, now notice here that it already gives us some commands to initialize our repository here. These are command line things. So I'm going to go back into our folder here. I'm going to create a directory. This is going to be the directory where my repository is going to live. So I'm going to call this guy, I'm just going to name it the same thing as we have here. So I'm going to copy that. Ninja. So I'll make that directory. And then I'll go ahead and CD into that directory. Now, we already have installed on Linux the tool git. So if you type in which git, it'll tell you probably user bin git, might be user local bin git. Let's see what it says. It's user bin git. Okay, so in the Linux file system, a directory that's called bin is where binaries live, executables live. All right, so things that kind of come with the operating system are typically in user bin. That's kind of like the operating system level executables. These are things that are part of the distribution, typically. User local bin. Oh, sorry. Are actually, there's nothing in there right now. These would be things that you installed yourself. So if you had something in your directory you compiled it and you installed it, it would probably go in the user local bin executables to kind of keep those segregated, but they're just folders, okay? Nothing says you can't put a binary in just some random lib folder or something like that. This is more of best practices for using your operating system and the intended use, okay? But our punchline in here is that was really a little thing on using command line, because that's something we want to get good at in here, because command line makes you feel like you're using your computer and you can do some very powerful things from the command line. That isn't to say that we don't appreciate the more powerful tools, okay? But these command line skills are going to become handy the farther you go into computer science, okay? So punchline here is if you type in which git like that and you see, oh, I found it in user bin git, there's evidence to us that the git command is already installed on Linux, okay? Came with it. All right, so we're gonna go ahead and make sure you're in the folder that you just created. So if you type in pwd present working directory, I'm currently in home parallel, blah, 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 blah. Ultimately, I'm in that GitHub tutorial directory I just created. You wanna make sure you're sitting inside that directory. Go ahead.
I feel like a personal note, when I type in which git, like nothing comes up. Jump down to the next line.
Nothing comes up. Are you on Ubuntu?
Yeah.
Weren't you the same one that didn't have, what else wasn't on your Ubuntu? Wasn't some other,
It wasn't.
G++ wasn't on there?
Yeah, it's the same thing for me when I use which git.
What kind of, like, where'd you get your install? All right, let's get git installed then. If you type in which git and you don't see it there in user bin git, we want to install it. So we're gonna go ahead and use a tool called apt-get. Hopefully you have apt-get. If you type in which apt-get like that, does something pop up?
Yeah.
Good. All right, so. Huh? Well, I'm guessing nobody. Where does get your install?
Ubuntu.com.
It's like the 20.04 or something like that.
From their website.
Maybe they just want to give you the skills and not the way to get.
Okay, well, and that's fair. That's fair. And if I'm just kind of going through it in my head, I think I'm running 18, and I'm almost positive that, in fact, you know, we're down the rabbit hole. Let me just check real quick. This is a fresh install of Ubuntu 18.04 Linux. And I definitely have not installed Git on this myself. Let's just see. Oh, it doesn't come pre-installed. That shocks me.
But you said this is 18.0.
Yeah, this is an older version. So I must have installed it myself. Okay.
18.04 is the same one that you are running.
Correct.
Okay.
Right. But I mean, it really shouldn't make a difference. Yeah.
Isn't it the sudo apt install git?
Yeah, we're about to do it. We're about to do it. So you're right. It's not something you did wrong.
Yes.
It's just
Finally, for one.
it's just a thing. All right. Well, so this will be another good practice. And actually those tutorial videos, if you go through all of them, which I do recommend you do that. I teach you how to a couple different ways of installing software in Ubuntu, like how to put VS Code on there through their installer software thing, and also how to do apt-get. So we're about to do apt-get. All right. So if you type in which git and you don't see anything there, that means you don't have the command that we're about to need. Okay. So good news is this is pretty easy to handle. We have a package manager inside of Ubuntu called apt-get, which actually came out way before Ubuntu. If you use other versions of Linux, Fedora Linux has a tool called yum, Y-U-M. Okay, so the first thing you're going to do, and you're always going to run this using sudo. Does anybody know what sudo means?
Is it an acronym?
It's an acronym.
Isn't it like super user something?
Super user do. Do this command as super user. Okay, because the alternative is I can type in SU and press enter, and it'll ask me for the super user password, and I become the root user. Okay, and that's typically considered to be a security concern. because then you can start like removing the entire file system and stuff like that. So instead, the preferred way of doing this is to say, when you do need to run a program as super user, just like in Windows, you can say run as administrator, but just that one program, you would say sudo, super user do. And what are we going to do? The first time you run apt-get, I encourage you to do this: sudo apt-get update. That'll just make everything, it'll bring all of its libraries up to date, and in case since you probably haven't done this before. So go ahead and do that. It'll ask you for your password for your Linux box, so go ahead and type that in. Okay. And it won't take very long. It's just going to go and hit the, in my case, it hit 7 different places that just kind of grabbed, sources of repositories for apt-get. Somewhere out there, people are keeping track of a bunch of, for Ubuntu, they're Debian packages. Ubuntu is a version of Linux that's built on top of Debian Linux, which is fairly famous old school Linux. Because really Linux is the core operating system is the Linux kernel. And that's standard across all of them. And then you have the distributions like Red Hat Linux, Fedora Linux, Debian Linux. And then you have some other distributions that say, hey, we like Debian Linux, but then we're going to put something else on top. And now it's more user-friendly. That's kind of the Ubuntu way. Go ahead.
You have the ones that look like the Mac OS, and you have the ones that look like the
No, those are the X windowing interfaces and that kind of stuff. Yeah, so you can do all sorts of stuff with Linux, but it's going to be more of a technology person's tool. Now, having said that, let's say that you told me I can only have one OS for the rest of my life, and I wasn't allowed to virtualize other OSs. I probably would pick Linux. Because it will give you the most flexibility for doing all sorts of different things that like you can, if you're running Windows, you're stuck with Windows windowing environment. There's some add-ons and stuff like that where you can kind of sort of modify it, but generally you're stuck with whatever Windows looks like, start menu thing and that kind of stuff. If you're on Mac, you're stuck with Macintosh's interface, which I always thought was funny because Apple people just say, oh, well, it just works, right? I don't think the Macintosh user interface is all that intuitive. Do you? I mean, most of us are not Mac users, right? Some of us are, but most of us are not. If you sat down on a Mac before, it's your first time, it feels pretty foreign. Windows has a little thing that says start. You click there, that's where you start. The stuff's in there. All right, so I always found that funny, how the Apple fan people, I was going to say fanboys, but we'll be inclusive. The Apple fan people are think that their stuff is more user-friendly than it is. I think the same thing's true with iOS, because I've been using Android for a while, and my wife uses iOS, and so we have both iPhone and Android in the house because I write software for both. But I don't use iOS on a daily basis. So I'm kind of out of practice with the user interface and all the gestures and things like that. Well, I started using my iPad. I started using my iPad a lot more because I've been playing, at 5 in the morning, I play Hearthstone for 2 hours and stretch in my kitchen. It's a real problem. My morning workout involves stretching at the sink with Hearthstone on an iPad. But I had to go through like a legitimate crash course on how to use the iPad with all the swipes and like I'm doing magic tricks in front of the thing.
Do the new iPads have like the home button or no?
Oh, I haven't had home button in a while.
Okay, really?
Yeah, no physical button.
Okay.
No fake button either, yeah.
I haven't seen the iPad in a while.
Yeah.
I haven't seen the iPad in ever.
Yeah. But punchline is, I don't think Apple's stuff is all that user-friendly. I think that if you look at like Ubuntu's user interface, this kind of takes a nod from Windows. Bottom left-hand corner here is where you start. Your stuff lives in there. Okay. So in any case, we're going to come in here. We've updated apt-get, so we have the latest, greatest packages or whatever. Go ahead.
Wouldn't you say though that Ubuntu kind of looks like the Macintosh with some of the applications in here?
Well, maybe, but if this is the Mac OS over here, I don't have a little thing down here. I got a zillion icons down here, most of which I put there, right? And the way, I mean, once you become a power user of Mac, then you find it pretty convenient. You know, I hit command. What did I just do? I was trying, I activated Siri. Command spacebar brings up Spotlight, and you can just do everything from Spotlight. If I want to launch Pages, I can launch it right from there. But that takes time for you to kind of get used to the way of doing that, right?
If I went from Windows to Mac, I would click on the top left button, the little apple.
Yep.
Yes, that would look like start button.
Sure.
I'm pretty sure it's not.
All right. Yeah, this guy would probably get you to the App Store or something. You can go to Go.
Okay.
Go would, you know, you can kind of get to your applications and stuff. But even then, you know, just got this wall of applications. You know, I don't think that's all that user friendly personally. So whatever, I think it's overrated. But in any case, you know, if I had to pick one, Linux would be it. But it also, I think Linux is very instructive for the kind of computer science way of doing things. Okay, it's a professional operating system. So we've updated apt-get. So now what we're going to do is we're going to say sudo. We're going to do this as super user. That way, anything we install will have the correct permissions to access different directories and things like that. So we're going to say sudo apt-get install git, G-I-T. Now it's possible that my version of Git is out of date. So it might even say, I'm going to update it for you. But for all of you, it should install it. So go ahead and press enter.
Have been not upgraded.
Oh yeah, so I can do that. I can do sudo. So I'm assuming for all of you, it's downloading Git and installing it. Is it already done? Or is it still?
It's not done, it's still working. So it's probably pretty close.
Sudo apt-get update. If you want to have apt-get update all your software on there, you can just say sudo apt-get update and it'll, oh, actually, hold on, upgrade. And it'll say, hey, here's all of these programs that we're going to update for you to get the latest, greatest, coolest, whatevers. So Y is capitalized. I'll just press enter and it'll download that stuff, presumably in the background, but I'll just launch a new terminal here. All right, so pretty handy, these package managers, as I just am basically updating all the software that's on my machine that's I've managed with apt-get. Go ahead.
What is the difference between upgrade and
Update brings the local list of available applications and the version available on the apt-get repository up to date. Upgrade says, upgrade any of my installed programs to the latest, greatest version. So I would say if you haven't run it in a while, always do an update first. So you make sure your local file lists all of the applications that are available along with all the most up-to-date versions. Yeah.
So the computer knows where to install the thing.
Yes, because apt-get is a package management tool that installs Debian packages. So whoever made that, Debian packages are effectively installers. So when you're on Windows and you double click on a setup file, what does it do? That setup file pops up. Sometimes it gives you a choice to choose where you want it, but it always has a default in there. And usually you just keep it next and it just installs it somewhere. Same thing's true with this. Most of it's going to go in user bin or user local bin, depending on whether it's kind of an operating system type thing, utility, or it's a kind of a personal whatever utility. All right, so right there, I just upgraded all of these old libraries, and maybe we'll see today what I just broke. So we'll see. I think we'll probably be okay. All right, so everybody has Git installed now. All right, so if you type in which Git, it now shows user bin Git. All right, we actually, yeah, you can probably say git-v. Let's just do git-h, and that'll give us a help. It's -- version. So a lot of times, so you kind of start learning the patterns. These are command line arguments to these programs. That's what that, you know, string array args thing is in Java. So Git, if you type in -h, or sometimes it's -- help, it'll show you how to use that command. So --version shows you version 2.17.1. Probably because you're using a newer version of the OS. Yeah. Okay. But I don't think Git's drastically changed in terms. It certainly is not going to change from the commands we're about to do, because I've been using these commands for, I don't know how long now, how long Git's been out, but since Git's been out, before Git, there was a program called CVS, source control thing. All right. So what we're going to do, I'll just clear this right now. We'll roll back 15 minutes or whatever it was, type pwd present working directory and ensure that you are sitting inside of the directory that is CSC300 _ whatever you named your folder. All right. If you're not, I'll just move up a directory. So right now I'm sitting in my directory CSC300 spring 2021. So if you're not quite in the directory you should be into, you need to do a CD. I'm changing directory into, type in the name of the directory you want to change into. And if you just start typing it and press tab, it'll do an autocomplete for you, or at least make a guess up to where it can make that guess, and you can keep going from there. All right, but punchline is you want to make sure that before you issue this git command that we're about to do, you are sitting inside of the directory that you want to be your repository. Make sense? All right, so the first thing we're going to do here, and they give you a cheat sheet over here on GitHub. We're going to initialize this Git repository. This is something you do one time per Git repository. So we're just going to type in git init, git space init. And it's going to say, we initialize an empty Git repository, blah, 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 blah. Okay, now, if you type in ls and press enter, you're going to see that your directory is currently empty. Okay, ls is a directory listing. But if you type in ls-a, it'll show you all files in your current directory. And notice we have something called .git in there. Any thing with a leading dot is hidden by default. So you don't see it unless you dig in to see it a little bit more. So if I did cd.git, we start seeing a lot of stuff that just got put in there for me.
And that single dot, is that a pointer to itself?
That's a pointer to the current directory.
And the dot is a pointer to the previous directory?
Yep, up one directory. Yep. All right, but punchline for us is you shouldn't go into that .git folder. We don't need it. That's why it's hidden from us. It's the thing that Git uses to manage your repository. But there's just evidence that something did happen after we said git init. All right, so from our perspective, git init should have just said initialized empty Git repository, yada, yada, yada. All right, so we're going to go back over to GitHub. Now, I usually skip the second one, the git add readme. You know, that's just adding a local file. I don't create a readme for most of my Git repositories, so I skip that. I'll go ahead and do the next one. We'll type it in. So I'm going to say git -m. Is it -m or is it git commit? Git commit -m. Git commit -m. And then I'll just say initial push, something like that. Okay, you can put whatever message you want. The -m says message. Remember with Git desktop, you always had to put a little note saying what this thing was for. That's what we're doing here. So I am committing the current state of my repository locally. I'm not talking to GitHub yet. Go ahead.
So it's cd and then dot, and you have the up directory?
Yes. All right. So locally now, I have, so this is on a branch called master, the branch that was created. I've now committed my current state of my repository, which has nothing in it, but it's still a repository. It's an empty folder. Okay. Then I'm actually going to skip the branch one too. You know, typically you use GitHub to have like a main line of your software development, but the idea is you might have multiple versions of a piece of software. So you might want to have kind of like the beta branch, and then you might have the production branch, things like that. For our homework, we're only going to have one branch, right? So I won't actually create a second branch, but we will use this next one. And I'm going to go ahead and I'm going to copy that line. So what we're doing is, this is also something you only need to do once. We are adding a remote connection to GitHub using Git. Now, Git knows how to talk to other Git repositories. So for instance, like Bitbucket is a competitor to GitHub. It's another Git repository, but GitHub's probably the most popular. So I'm going to go ahead and I'm going to copy this line. So I'm going to add a remote connection called origin to this local Git repository. So I have to right click and hit paste. All right. And I only need to do these commands once. I only need to initialize a repository one time. I only need to do an initial commit once. And I only need to add this remote one time. All these commands are one time per repository you create. So for each homework assignment or each new folder you would create that you want to have a new repository, you would have to add this add, because notice this guy is related to my GitHub project specifically. So just press enter. You probably saw nothing as feedback. It just worked. All right. Now I can go ahead and I'm actually going to skip. I'm going to steal this line. Well, I'm actually not going to steal the line. We're going to test it here. I'm going to go ahead and let's just create a quick file in here. So I'm going to copy / hello world.c into my local directory. So here's an example of using all those dots and stuff. So I'm copying a file. What file am I copying? I'm copying hello world.c that lives one directory up from me. / says go up a directory. The name of the file is hello world.c. Where am I copying it to? I'm copying it to the current directory. All right. I'm just giving myself a quick file to add to my repository. All right. So now if I type in ls, I should see I have hello world C in this folder. All right. So now I've made a change to my local repository. So I need to say git commit -m added a file, something like that, whatever the message is. All right. Actually, before I do that, I need to add those files. So I'm going to say git add star. Then I'll say git commit added a file. All right, so it's now added that file to my repository. So whenever I add a new file, whenever I make a change to a file, I need to make sure I do a git add star so it's tracking all those files. There's some other commands you can use instead of git add star. There's like one that ignores certain things, but for us, git add star will be good enough. All right, at this point in time though, all I've done is I've updated my local repository. We haven't actually pushed anything up to the cloud yet. The last part is git push -u. So git push -u. Now I'm pushing it to origin. And if you remember up here a little bit, when I created my remote, I called it origin. Origin is like the variable name associated with this remote repository. I made that. I made a variable called origin, which is linked to a web link to GitHub. So I'm doing git push -u origin, and then I need to tell it the repository, the branch I'm uploading. We didn't create that main branch like they had told us to. Our branch is called master. So git push -u origin master. All right, it's going to ask me for my GitHub, only the first time. Will it ask you for your GitHub username and password? So go ahead and put that in. The password will be hidden when you type it, I hope. All right, so it has now uploaded it to GitHub. So if I refresh on the screen, we have our file. See, easy peasy, just memorize 4 million commands, you're good to go. Okay, now I'm going to show you how to make life a little easier for you. The initializing thing isn't that big a deal, right? You do the git init and then a couple things. And like I said, on GitHub, it gives you the cheat sheet for those. But I'm going to show you how to create an executable batch file that will allow you to just run one command and it'll just do everything we just did at the end. All right. So we'll go into Visual Studio Code to write this. Typically, if I was writing this, I would do it in VI. I would use a command line text editor to write it, but we're going to be doing our stuff inside of Visual Studio Code. Yeah, and one of the things I like the best about Visual Studio Code in here is how it rarely just works and shows up and things like that. It's really quite nice. What's the point? Let me quit that and relaunch it.
I usually open it and then it won't open, so I open another one and then it'll open both at the same time, which is my usual.
Actually, I could probably say, that is really like not good. Is Visual Studio Code this bad on here always?
It is a little bit slow running, starting it up.
It looks like maybe I'm running an old version.
We did break something.
That's okay. We'll fix it.
Breaking things is productive on that.
I'm guessing that's what it was, is I probably updated a library that the old install of Visual Studio Code used. So it wants me to update Visual Studio Code to be the new version of Visual Studio Code. And it also looks like I had previously installed Visual Studio Code from the command line, not using the Ubuntu software thing. It must have been prior to when they had it available on there.
So on that, I have a quick question.
Yep.
Is there anything else that you can think of that maybe wouldn't be installed on others that you thought would be?
Well, you said G++ wasn't installed. Yeah, so for G++, you would have said.
I don't think sudo application was. I think at least for mine, it was like something really complicated.
Really? Sudo apt-get. Well, yeah, so GCC is the compiler collection.
Okay.
So G++ you said it couldn't find?
I could.
Yeah, it knows about it. G++, it knew about it. GCC will give you the entire compiler collection, which I also already have on here. But it's the same tool. Sudo apt-get install thing you're missing. All right, so let's try launching this guy. Let's see if there we go. Works a little better. So let's say close others. We'll close this. Here's my, there we go. Oh. All right, so here's that folder. I'm going to go ahead and create a new file in this folder. So I'll right click and say new file. And I'm going to call this guy push. All right, so it's just going to be called push. Go ahead.
So I keep trying to upload to GitHub, but it keeps saying like can't access, right? Or something like I'm not logged in or something. Like how do you log in?
Well, the first time you access, you would have done the GitHub thing. It would have asked you for your username and password. So you have to go back through and do the tutorial of what we just did.
Is that for you to please tell me who you
Get in it.
Well, no, when you actually go to push it to Origin, it would have asked you for your GitHub username and password. So some step along the way, you didn't do something. All right, so we're going to go ahead and put those couple of commands in here because effectively every single time we want to take our current state of our program and put it up on GitHub, what do we need to do? We need to commit locally. We need to, we need to add the local files. We need to commit locally. We need to push Origin, right? So we'll do a git add star. Actually, I think add dot also works, but I'm just going to say add star. Git add star. And I'm going to say git commit -m. Now we're going to have to kind of hard code in a message. As a good GitHub user, when you're working in collaboration with other people on a big project, your messages probably when you do commits probably should be meaningful. Like, hey, I added this function or fixed a bug somewhere. For us, we're trying to keep it as simple as we can for us, right? And there are some GitHub things in Linux would let you do this graphically, but I think this is gives us some power, gives us a feel for some of the power you can do with the operating system. So I'm going to say git commit -m change stuff. That'll just be the message we give it every time. All right, then I'm going to do, what was the, let's go back out to the terminal. Git push -u origin master. So git remote, actually, no, hold on, that's the wrong one. I didn't copy it. So copy. Now I'll paste it. So the three things we want to happen every single time we are ready to push our changes to GitHub: git add star, git commit -m, give it some message, then git push -u origin master. Make sense? So I'm going to go ahead and I'm going to save that file. So now I'm going to go back out to my terminal. And inside the terminal here, we see we have our hello world.c, and we also have this file called push. If I go ahead and I type in cat push, this will show me the whole contents of that file. So you'll see it out here at the command line, so we can show it's the file we just created. All right, we want to make this file executable. So we're going to change the mode of this file. So we're going to say chmod. And we're going to say 755. That's going to be read write executable by the owner, and then read and executable by everybody else. So that's 7, that 5, that 5. It's an octal designation. Okay, so 7 means read write execute by everybody. Owner, well, the first number here is the permissions for the owner, which is all permissions. The second thing is the permission for the one's group, one's everybody else. So the second one here is the permissions for people who are in the same group you're in. if you happen to be a member of like an administrator group or something. So I'm saying you can read it and you can also execute it. That's what 5 means. The last 5 is for everyone else. So I'm changing, you only need to do this once for a file. So I'm changing the mode of this file to 755. What file? The file called push. So now if you type in ls, you'll see that push has probably turned green. All right, so it is a executable thing now. Now I'm going to go ahead and I'm going to make a small change to, oh, I'll make a small change to my file here to hello world.c. I already made some changes, but here we'll just do a printf hello world. Put that in there. All right, so I updated my source code file, and now I want to get the stuff up to GitHub. Go back out to my terminal, just do a /push. And now it's up there on GitHub. So there's my updated file here. That makes sense? So once you get it working once, you can put those commands inside of a single file, then make that file executable. And now whenever you need to add, commit, and push, you can just do that one command and it'll just do it. All right, questions about that stuff? I know it's a lot of moving parts, but once you get used to doing it, it's not that big a deal. And like I said, GitHub gives you a cheat sheet for the first part of it. And even if you follow their whole cheat sheet, you create a branch called main, that's not going to hurt anything. I just use the default branch of master. Why create a second branch if I'm not going to have multiple branches? All right, so that is the cadence for talking to GitHub from Linux. Whether we're doing C++ stuff, C stuff, you want to just have a folder with your papers from your English class, whatever it is. All right, so we're gonna, oh, why do I keep clicking that? Gotta click the one that has the red dot next to it. That's the one that's open. All right, so I'm gonna go ahead now and we're gonna get rid of this hello.c because this actually isn't a file that we want to have in our this particular thing. We're going to go ahead and we're going to create a template for a default hello world C++ file, which we actually have right here. So I'm just going to steal some of the stuff from main here. Let's just steal all of this. So I'll go into my folder. And we are going to, what am I doing? I'll right click, we're going to create a new file. I'm going to call this guy driver.cpp. So I'm kind of keeping with what we used to do. Go ahead and paste some stuff in here. I'm going to get most of this stuff gutted. Okay, so we can call this kind of our starting template for our C++ programs. All right, now we're going to go ahead and we're going to create a header file. So I'm going to right click out here. I'm going to say, and actually here, I can show you a starting point for this. So here's an example of a header file. Now notice how this kind of reads as documentation. We have the name of our class, and then we have private and public sections. And notice that the constructor must match the same name as the class name. All right, so I'll grab this as my starting point and we'll modify it because we're going to create a little dice roller thing. I'm doing this mostly for time since we've got a few minutes left. So I'm going to create a new file. We're going to call this guy dice.hpp. I'm going to create the header file for my dice object. So I'm going to be creating a class called dice, and it's going to have private variables for int sides. And then I'll have a constructor for dice that takes in my number of sides initially. So a simple little object. I haven't given any abilities yet. Well, we probably are going to have an ability, so we'll probably have something like int roll, like that, where we will be able to roll a dice. All right, so now we're going to go ahead and we're going to create our implementation. That header file is kind of like an interface from Java. Our implementation will be inside of a CPP file. So I'll just kind of steal this here real quick. So I'll create a new file. This guy will be called dice.cpp. Now I'm going to notice up top, I'm including double quote, dice HPP, double quote, where these other includes have the angle brackets. Whenever you have a double quote around something like this that says, look in my directory, this is one of my header files, one I wrote. The angle bracket ones means, these are things that that somebody else wrote that I want to bring into my, my class. All right. Now, here's our implementation of the constructor. In my dice HPP, notice I had a constructor prototyped here. So I said there's going to be a constructor named dice that takes in a number of sides, int sides. Now, the CPP file, that's when I actually go and implement the interface defined in the header file. So over here in the CPP file, I'm going to say, here is my constructor. It belongs to class dice from that interface. So I need to say dice : this. I could also say using namespace dice, like that. And then I would not need, I would need to define it as a namespace. We're not doing that right now. Pretend like I didn't say that. This looks cooler anyways. All right, so we're going to say from the dice class, we're going to implement this constructor. Now we have this syntax here, pretty similar to Java, right? Where we say this dot sides equals sides, but notice it's using this syntax that has an arrow next to it. Now I'm going to show you, this is syntactic sugar for something else. This is star this dot sides is equal to sides. These two lines say the same thing. This says, give me the value. So this is a memory address. It's a pointer to this object that we're creating. This says, give me the value at that memory address and let me set the value of one of his fields. But we have a nice syntax. This is called a pointer to a pointer. We have a nice syntax that says this arrow sides, which effectively does this guy for us. Choose whichever one you like better, but the arrow one's going to be the common one, right? Otherwise, it's a little bit tedious to write all those extra parentheses and stuff like that.
You go back to the header file briefly.
That good?
Yeah.
All right, so this is my constructor. I'm going to set the sides equal to whatever size was passed in. Now, for a random number generator, we the reason we brought in time.h, you can seed the random number generator with the current time in milliseconds. This is something called an epoch. So it gives you the number of milliseconds since January 1st, 1970 is typically what an epoch is. Doesn't matter, but every single time you run your program, that should be a different number, giving you a random number generator that hopefully is pretty random. All right, where you run the program multiple times, you don't get the same thing. Java kind of does that for you behind the scenes. It used to not do that. So when you use the random class in Java, random r equals new random, and you said r.nextInt, historically, you would get the same sequence of numbers every single time you ran your program because it didn't self-seed to a different starting value behind the scenes. Go ahead.
In the header file, there was a semicolon after the last bracket. Is that a header file thing, or is that?
It is, because this is actually a block statement, and statements end in semicolons.
But C++, like in the regular language, is the header file?
Correct. Yep, it's the same as you did before. Because what's actually happening here is when we say include dice HPP, all that line is turning into is the exact stuff that's in here. It's just expanding it for us. So that's why the header files, they're not required, but they're nice because now we can just go and glance at our header file and say, this is what a dice object can do. It's implemented someplace else. Somebody wrote all the extra jazz someplace else, but this is what it knows how to do. All right, then the roll method just returns a random number, number of sides, blah, blah, blah. Okay, we'll go through and we'll compile this on Thursday because we are out of time, but compiling it's pretty easy. So I'm going to expect everybody's going to know how to use GitHub for, well, before you turn in your first homework assignment. So make sure you practice with that. The homework I actually do on Thursday is to make sure you've all gone through the virtual machine stuff. So lots of good technical stuff to do this week for a practice for Thursday. Yeah.
So theoretically, could you put your header file and implementation in the C++ file?
Yeah. Yep. Like I said, all this does up top here, when you say include this, it literally will replace that line with the contents of your header file for when you go to compile it. I would say that's probably bad programming practice, but that even was the way it used to be done in C, is instead of having a header file, a .h file in C, you would actually just prototype all your functions at the top. So, and it was for a one-pass compiler. As the compiler went through line by line, it would say, when you implemented it later on, you said, oh yeah, up above, you told me you were going to do this. It's called a function prototype. So now the kind of the right way of doing it, it's almost like an MVC type thing. We keep the two things separated and say, this is our design, this is our implementation, that type of thing. Cool? Questions, comments, concerns, bribes?
I have a question about Visual Studio Code.
Sure.
How do you get the, like on the left there, you have like all those, you have like all of the folders on the left of Visual Studio Code.
Yeah, over here.
Uh,
Oh, these guys?
Yeah.
Okay.
How do you get that? Because mine just says no folder.
I'm guessing under view, maybe. Explorer. I'm thinking it's Explorer.
Mine still says no folder open. Do I just have to like open a folder?
Oh yeah, probably, yeah.
File, open folder.
Okay.
Well, actually, you can also do add folder to workspace. That did it too.
Okay, and then do you just recommend opening just like the highest level folder?
I don't know if I recommend that, but that's what I kind of do. But that has more to do with I just don't write with Visual Studio Code that much.
Okay. Sounds good.
So whatever makes your life easiest.
All right, sounds good. Thank you.
Yep. So. Let me
I
stop
tried
the,
to figure this out on my own too, but I can't. I think I got a similar error with someone